Welcome everybody, you're watching 𝗓𝗂𝗍𝗲 Data Science. Feel free to reach out on socials. Today we will discuss vector databases in a podcast format made with Notebooklm from Google.
Let's dive right in. Today we're tackling vector databases. You've probably heard the buzz, but get this. Imagine trying to find a needle, not just in a haystack, but in a haystack the size of, well, the internet. That's the challenge we're facing with the explosion of data, especially the unstructured kind like images, videos, and text.
Yeah, it's true. Traditional databases, they were built for neatly organized data, spreadsheets, rows, and columns, that sort of thing. But think about it, 80% of data by 2025, it's going to be like trying to fit square pegs in round holes. Unstructured data needs a different approach, and that's where vector databases come in.
Okay, so vector databases. Can you paint me a picture? What are we talking about here?
So instead of a spreadsheet, imagine a vast digital map. Vector databases, they represent data as points on this map. Each point is defined by a set of coordinates, and these coordinates are called vectors.
Okay, I think I'm starting to see it. So instead of searching by like a name or an address, we're searching by similarity. Kind of like finding all the pizzerias within a certain radius on a map app.
You got it. It's all about finding data points that are close to each other on this map, even if they don't share any exact keywords.
So instead of just matching words, we're matching meaning. That's a game changer.
Exactly. It's like when you search for images on your phone, you're not looking for an exact pixel for pixel match, right?
Yeah.
You're looking for pictures with similar vibes. Vector databases make this kind of intuitive search possible for all sorts of data.
This is already blowing my mind, but how does it actually work? How do you turn, say, a cat picture into a set of coordinates?
That's where the magic of machine learning comes in. Sophisticated models analyze the data. Think like 𝗓𝗂𝗍𝗲𝗏 for text, or convolutional neural networks for images, and they transform that data into those coordinate points, those vectors. And these vectors, they essentially capture the essence of the data. It's a unique fingerprint, you could say.
Hold on, let me see if I've got this. It's like each cat picture gets analyzed for things like ear shape, fur color, even that mischievous glint in its eye. And all these features get translated into a string of numbers. It's unique vector.
Precisely. Each number in the vector represents a specific characteristic or feature. So you might have a vector that looks something like this: 0.23, 0.54, 0.32, 0.12, 0.45, 0.90. And this string of numbers, that becomes that cat picture's location on our digital map.
Okay, that makes sense. But now imagine you have like millions, billions of these data points, each with its own vector. How do you find anything in that massive mess? That's like remembering that needle in the haystack.
Right, and that's where specialized indexing techniques come in. Vector databases use algorithms like something called HNSW, which stands for Hierarchical Navigable Small World Graphs.
Hold on, HNSW, what's
imagine
that all
a complex maze. HNSW basically creates shortcuts through that maze, making it much faster to navigate. In the context of vector databases, HNSW is creating those shortcuts through your data, making it possible to find similar vectors incredibly quickly, even with massive data sets.
So instead of searching every single data point, it's like taking strategic shortcuts to find what you're looking for.
Once you've found similar vectors, you can measure just how similar they are using something called cosine similarity.
Cosine similarity.
It's basically a fancy way of saying we're measuring the angle between two vectors. The smaller the angle, the more similar the data points are. Think of it this way. In our map analogy, 2 points that are close together have a smaller angle between them than 2 points that are further apart. Vector databases make this kind of intuitive search possible for all sorts of data.
Navigating with HNSW and then measuring similarity with angles. I'm starting to see the power of this, but can you give me a real-world example?
The magic of machine learning comes in. Sophisticated models analyze the data. Think like 𝗓𝗂𝗍𝗲𝗏 for text, or convolutional neural networks for images, and they transform that data into those coordinate points, those vectors. And these vectors, they essentially capture the essence of the data. It's a unique fingerprint, you could say, creating a playlist of recommendations tailored to their taste.
Okay, that's cool. But is it really that much better than what's already out there? What's the big deal about vector databases? What makes them so revolutionary?
Speed. It's the ability to perform these complex similarity searches with incredible speed, even across massive data sets. Think about it for AI applications that need to react in real time, like fraud detection or personalized recommendations on the fly. That speed is everything.
Speed. Okay, yeah, that makes sense. But it's more than just music recommendations, right? What are some other ways vector databases are being used?
Oh, tons of ways, like online shopping. Imagine you're just browsing for a new laptop, and bam, the website suggests all these accessories that are perfect for you based on your past browsing history. That's vector databases at work.
Wait, so that time I saw an ad for a vintage record player after looking at vinyl, that wasn't just a coincidence.
Companies like Shopify, they're using vector databases to create these really personalized shopping experiences way beyond just basic recommendations. And it's not just about sales either. It can even be used for content moderation. Platforms like Facebook and Twitter are using them to fight the spread of, harmful content.
So instead of relying just on keywords, they're analyzing images and text for similarity to known examples of hate speech or misinformation.
Exactly. It's like having a superpowered content moderator that can spot problematic content in real time, making online spaces safer for everyone.
Okay, yeah, that's huge. From shopping to a safer internet, what else can these vector databases do?
How about revolutionizing drug discovery?
Okay, now you're just showing off. But seriously, drug discovery.
I'm serious. There's this company called InstaDeep. They've created a vector database containing something like 12 billion molecules.
Hold up, did you say 12 billion?
12 billion, each represented by a unique vector capturing its chemical properties. Pretty amazing.
So it's like a digital fingerprint for every single molecule on the planet, or at least a lot of them.
Right. This database, combined with AI, it's accelerating the search for new drugs and treatment, basically by analyzing the vectors of, existing molecules, comparing them to vectors of potential drug candidates. They can predict effectiveness, identify side effects, even design new molecules with specific therapeutic properties.
Wow, that's incredible. So we've gone from a needle in a haystack to a map that leads you straight to the needle, except instead of a needle, it's, life-saving drugs.
Yeah, it's a pretty powerful tool. And it gets even better. Think about conversational AI. We've all interacted with chatbots, and, most of them are kind of clunky. But what if your chatbot could remember your past conversations, understand the context, and respond in a way that felt, genuinely human?
Okay, now you're talking. Sign me up for a chatbot that can actually hold a conversation.
Well, companies like Replica are using vector databases to build exactly that. By storing and analyzing past conversations as vectors, these advanced chatbots can learn from experience, understand the nuances of language, and provide a much more personalized, engaging interaction.
So it's not just about matching keywords anymore. It's about understanding the meaning, the intent behind the words.
Yes, precisely. It's like having a chatbot that can not only understand what you're saying, but also how you're feeling and what you might need.
Okay, I'm convinced. Vector databases are definitely the future. But let's say someone wants to get started with this. Where do they even begin?
That's a great question. And, it is a rapidly evolving field, but there are definitely some major players leading the charge. One of them is Pinecone. They offer a fully managed vector database service. It's known for its performance and scalability. Basically, it can handle those massive amounts of data and still deliver those lightning-fast search results.
Sounds impressive. And what kind of companies are using them?
Oh, big players like Microsoft, Shopify. They rely on Pinecone for their data needs. But Pinecone isn't the only game in town.
Okay, good to know. Who else is out there?
If you're into open source, there's 𝗲𝗏𝗄, highly scalable, with a strong community backing it up.
And who's using 𝗲𝗏𝗄?
Companies like Salesforce, Zomato, they're using it to power their applications. But really, it just depends on your needs. For example, a company like Discord, they need those real-time updates and that super precise search capability. They might choose something like 𝗬𝗏𝗏.
So we have Pinecone for those bigger companies, 𝗲𝗏𝗄 for people who like to work with open source, and then 𝗬𝗏𝗏 when speed is really important. What other options are out there?
Well, if you're looking for something that's known for being user-friendly, flexible, especially for AI applications, there's Chroma, and then Weaviate. It's cloud native and has a really user-friendly GraphQL interface. It can feel that way, but honestly, it's not as overwhelming as it seems. The best vector database really depends on your specific needs and priorities.
So things like scalability, for example. If you're a huge company dealing with tons of data.
Or budget considerations, how well it integrates with your existing systems, and of course, what specific AI applications you're building. Like if you're just starting out experimenting with a new AI project, you might not need something as robust as a company doing huge enterprise level work.
So it's all about finding the right tool for the job. But with all this talk about these advanced databases and AI, it's easy to forget, which brings us right back to those billions of data points, each with its own story to tell. It's almost like we've been trying to solve this massive jigsaw puzzle with all the wrong pieces. And now with the vector databases, it's like we finally found those missing pieces that make everything fit perfectly.
Yeah, that's a great way to look at it. We're moving away from forcing our data into these rigid structures and embracing a much more, intuitive and flexible approach.
And the possibilities, like we've said, they really are endless. Personalized recommendations that actually make sense, content moderation that helps create safer online spaces, drug discovery that could change the entire landscape of human health. It's pretty mind-blowing, to be honest.
And we're just scratching the surface. As AI keeps evolving, vector databases will be right there with it, powering even more sophisticated applications, things we can only dream of right now.
It's like we stumbled onto the launch pad just as the rocket ship is about to blast off.
I love that analogy. And the best part is, anyone can be along for the ride.
Exactly. Whether you're, a data scientist who's been doing this for years, or you're just starting to dip your toes into the world of AI, there's a place for you in this vector database revolution. So for everyone listening out there who's now hopefully just as excited about vector databases as we are, what would you say is the key takeaway? What's the one thing they should remember from all of this?
That's a good question. For decades, we've been trying to fit our square, unstructured data into these round holes of traditional databases. And vector databases, it's like finally discovering that star-shaped hole that fits perfectly.
Okay, yeah, that's a brilliant way to put it. No more struggling, no more forcing, just elegant solutions for our data needs. As we wrap up this deep dive, I have one final question for you and for all our listeners. What will you unlock with the power of vector databases? The possibilities, as we've discussed, are pretty much limitless. Until next time, keep exploring, keep learning, and keep diving deep into the fascinating world of data.
Run free and dive into the sky. Hear the